All right, good morning. It's a pleasure being here in front of a great number of developers. Thank you for the opportunity to be here. I'm going to talk about design patterns, and this is a topic that's been around for a long time, but I'm going to talk about design patterns with respect to modern JVM languages, and we'll see what that means in a few minutes. But before we get started, let me start out by saying I really hate design patterns. There you go. That was very motivating, wasn't it? And let me explain to you why I think design patterns are not a great idea if used in a wrong way. Now, imagine for a minute, you know that grandma makes the best pie. Nobody can make better pie than grandma, right? So you go to grandma and say, Grandma, you make the best pie. I got a bunch of friends coming over. I've told them all about your pie, and they want me to make it. So give me a recipe. And grandma gives you the recipe. You say, let me write it down. And grandma says, put some flour in it. You say, wait, how much flour? Then grandma says, put some sugar. You say, no, tell me exactly how much sugar. And grandma says, about 2. Is it 2 teaspoons or 2 tablespoons? You write down meticulously, and then you ask grandma, one more question. What are the best practices? What are the do's and don'ts? And then you go home and try it. And then when you tried it, how did it turn out to be? No, it was a disaster. Last time I tried it, I couldn't get the spoon out of it. And of course, you hide the pie, go to the store, get it, get over with the party. Then you go to grandma and say, Grandma, it was a disaster. And grandma says, why? It's really simple to do. Well, simple for you, of course. Can you do it? And grandma goes to the kitchen and she starts making the pie. So she takes sugar, measures very accurately, and puts it, right? No. She put some sugar. So what was that? Sugar? How much do you put? Enough. And that's when you realize grandma doesn't follow any recipes. Well, this is what happened. Back in '94, just about time Java came out, there was these 4 guys who were the grandpas and grandmas of our industry. And the worst thing they ever did is write that book called The Design Patterns. And everybody thought they could read that book and immediately become expert programmers. What a sad story. But having said that, I think design patterns have definitely value, and the value really comes in how we use it to communicate. How do we exchange our ideas? How do we tell what our intention is and what we're trying to do? So that's what I'm going to show you here is a few patterns we could use. So I talked about why we want to use patterns. I use it as a communication tool, and what are some of the reasons not to use it the way that we've been trying to do as a design tool. So in other words, use patterns to communicate, use patterns to explain to people how you solved a particular problem. But on the other hand, don't use patterns as a way to sit down and say, here's how I'm going to put the design together. In fact, if you're getting off the bed one morning, and the first thought that comes to your mind is, I wonder what pattern I will use at work today. Call in sick. Don't go to work that day, right? Not worth doing the design that day, right? So let's talk about a few patterns. The first pattern I want to talk about is the so-called Iterator pattern. And I'm going to use Groovy here as an example for this particular pattern. I'll switch between languages just to show you different flavors. I'll also use Java here eventually as an example. So one of the things I want to show you here is Iterator. We've all used iterators for a long time. Let's say for a minute we have a bunch of numbers on our hand, numbers equals. And let's say we have numbers 1, 2, 3, 4, 5, and 6 as the numbers. And I want to be able to loop through these numbers and print them out. How would I do that? For int I equals 0, I less than numbers dot length. Is it length or is it size? I can never remember that. And then I plus plus, right? And then you take a pause and say, is this really less than or equal to? There's a name for this pattern. It's called self-inflicted wound pattern. There is no reason to be writing code like this, right? I mean, this is 2013. We shouldn't be writing a for loop like this. A notch better than this in Java, of course, is the for each statement. We could say int number, for example, in numbers, we would write it like this in Java. But we don't have to do that anymore. We could use what are called internal iterators. So what is the difference? An external iterator is kind of like a rude dog. It doesn't want to move. You got to keep pushing it. An internal iterator, on the other hand, is much more, easy to work with. Rather than focusing on the actual iteration or how to step through the collection, you're more focused on what you want to do per element in the collection. Let's think about this for a minute. Suppose I were to write numbers, and I want to loop through each of these. I would simply say each, and I'm going to say print, and I want to print the values in this collection. This becomes the internal iterator simply to step through the code and print its elements. Well, that's quite convenient. But what if I want to double the values in the collection? Now, let's think about how we would do this in Java, the old way of doing things. You would first create an empty array of a collection, right? And then you would loop through each element. And within the loop, you would take each element and you would double it. And then you would insert it into the collection you created. Anybody who has done that? Everybody has done that. How do you feel when you do that? Dirty, right? You go home and kids come running over to you, say, don't touch me, right? I gotta go shower first. I mean, that's so really, really pathetic, right? The way we have to do it. We don't have to do any of that. We could simply say numbers.collect. In the case of Groovy, of course, we could just say collect. In the case of Java, Scala and other languages, including Java 8, we would use a function called map. So we simply map the elements and print it, and you can see how concise. This is called the declarative programming style. Rather than being imperative, we're being declarative. Good news is you can do this in almost any civilized language today, including Java, when Java 8 comes out. You can certainly do something very similar to this. Now, on the other hand, what if I want to only get an even number from this collection? Again, think of this. How would we do this in the traditional imperative style? First, you would create a variable for the even number. Then you would write the loop, and within the loop, you will check if each of the number is even. If it is, you would set this variable. When you come out of the loop, you have to test if the variable was set or not. Not very pleasant, isn't it? How would we do this in the iterative style, internal iterator style? We could simply say, for example, numbers.find. And what am I looking for? I want an even number, so I'm just doing the test for the even number. That gives me the first even number in here. Or I could simply say find all and get all the even numbers in this collection. Now, a last one I want to show you here. You are asked to go through the loop and print out each of the numbers in this collection. How would we do that? So we could do something like this. We could say for, and then we could start with the number. So number in numbers, and then we could probably say something like print and print the number we have on our hand. Well, but I don't want to print them all in separate lines. So what do I want to do? I would say print like this. Oh, wait a second, but I want them to be spaced out. How would I do that? Well, let's do this. I would say number over here, and then I would probably want to say a comma. And then you look at this and say, hey, wait a second. There is an ugly comma in the very end. How do I get rid of that comma? Everybody has gone through this, right? Yeah, and that night was the saddest night. Because you looked at this and said, how do I get rid of that comma? And you thought, maybe I will create the string, then I'll go and remove that string. How did you feel? Dirty. Or you said, I'll loop through, but I will check if the I is the last element. If it is the last element, I won't print the comma. How did you feel? More dirty, right? And that was a sad night because you went to sleep without solving this and you said, man, this has got to be simple. Why is this so hard to do? Well, it turns out we don't have to worry about this so hard. We could do this very easily, and we could simply say numbers.join, and then tell him that you want to join using a comma. The day I learned about join, I cried that night. This is like amazingly cool, right? So simple, high level of abstraction for us to work with. What a great way to write code. You could do this with iterator pattern, and that is what you're looking at here. But what are we doing here? I'm using Groovy, obviously, but let's quickly take a look at Groovy and say, what am I dealing with? And you look at this, and then comes the shocker. This is nothing but Java util array list. You say, wait a minute. That is Java util array list, the one back from high school? She never looked that cute back then. It's amazingly cool, isn't it? What a transformation. That is one of the coolest things about this is you didn't reinvent a data structure. You basically took an existing data structure and made it lightweight. That's one of the really good advantages that Groovy actually offers, and we saw how to use that here with this particular pattern. Anyway, we looked at the iterator pattern. That's great. Let's go on a little bit further and say Cascade pattern. Now, pretend for a minute this is Java code for a second. So I have a class called mailer. Of course, you could say public mailer if you really want to. And then I'm going to have in here a function called to, which is going to take an address. So let's say address. Again, pretend this is Java, so you could have more code like this here to say public, void, and all those good stuff. Let's ignore all of that. So I'm going to say to, and I'm going to also have a from, a subject, a body, and a send. So this is going to be a from, and I'm going to also provide over here, maybe if this was really Java, I would say public void. So let's go ahead and say this is public void, right? So what I have here is a from, and this is going to be a from over here. And I'm going to say subject. So let's go ahead and say this is going to be subject. And this is going to be some subject I want to put. So let's call it subject, and this is going to be subject. And then, of course, I want to say this is going to be a message. Let's put the body of the message right here, and this is going to be the message. And finally, here I have a method called the send method, which is going to send the mail. And this is going to simply say sending, right? So very simple API. You can put more stuff around it, but let's get to the way to use this. So mailer equals new mailer. So we got the mailer. And mailer.to, and you want to send this email to somebody. Whom am I going to send it to? How about myself? And I'm going to say mailer.from. Who is this going to come from? It's going to come from my build machine, actually. So let's call it as builder@agiledeveloper.com. Mailer.subject. It's got to tell me about something, right? It's going to give me a very important message. It says your code sucks. And finally, it says mailer.message, fix your build, whatever it wants to tell me, right? And then finally, it says mailer.send and tells me how to send the mail. So this is a little example. Anybody who has written code like this? Absolutely, right? This is how we write Java code. Now, when you look at a code like this, what's wrong with this code? The first problem with this code is, look at the noise in the code. Mailer, 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 mailer. You would never do this to a fellow human being, would you? They would strangle you, right? Because it's getting tiring when you keep hearing the word mailer so many times. The second problem with this code is, what do you do at line number 15? Are you done with the mailer? Do you want to throw it away? Or can you reuse the mailer? Well, of course, somebody would say, go read the documentation. We know how that goes when we try to read documentations, right? So we're not sure, how do we proceed with it? Let's think of a few ways to solve this problem. Well, even in Java, we could solve this problem using what's called a Cascade method pattern. So the first thing we will do in Java, by the way, is simply go back to this code and change this a little bit. We'll say return the mailer from each of these methods. So we're going to deviate from the convention a little bit, and then we're going to say in this particular case, rather than finishing this up, return the current object when you're done with this, right? So this is in Java, you would return the self object at the end of each of these methods. And once you do that, and what you can do in that case is, I haven't made the change to the code in the bottom yet, we'll do that in a second. And then we can go back to this code, and now we can get rid of all this noise of mailer. And then we can get rid of this object we create here. We can get rid of all these semicolons. We are simply chaining these objects together. This reduces the noise just a little bit. This is called the Cascade method pattern, also favorably known as the train direct pattern. And so you can basically write this code in Java by just deviating a little bit from the convention. You probably have seen this in various libraries, like ECMOC uses this, Juice uses this, various other libraries use this kind of format. That's great, we can do this. But still, that doesn't solve all the problems we talked about. Sure, it removed the noise a little bit, but still we're not sure what do we do with this object when we are done. Nothing stops us from storing this object and then calling more methods on it. So how do we prevent that from happening? So in here is what we can do using Lambda Expressions. So for almost everything I'm going to talk about in this session here, he's going to use Lambda Expressions one way or the other, because Lambda Expressions change the way we can use patterns in a very nice, effective manner. So let's take a look at an example of what we're going to do here. So I'm going to go back to this code, and I'm going to make a small change. I'm going to send a block to the send method. And then within well, of course, pardon me here, I'm going to revert back to the old code we had a minute ago, because we don't need this step here. So let's step back to the old code. So let's make sure that's working still. All right. So I'm going to go back and say, this is the block I'm going to send. And within this block, I'm going to receive a block of code. and I'm going to simply call the block of code and send a mailer to this. Now, what is this mailer that I'm sending? So I'm going to say mailer equals new mailer. So I created a mailer object, and I'm sending it to this block of code. We could go ahead and make all these methods. You could make the constructor private, for example, if you really want to do that. So, but in this case, I'm no longer going to create a mailer, and I'm going to say mailer.send, and then I'm going to send a block of code to him. But notice the send is being called on the mailer, so for that, I'm going to make this method a static method. So now the mailer send method is a static method. I can just call this method on the object, on the class rather, and then within the send method, I'm going to pass a block of code. So I'm going to move this code in here, remove the call to the send, and of course it's complaining that it doesn't know what a mailer is, but we will tell him what a mailer is, and you can see that we passed a mailer to him. So you can see how the code still works. But what did we do? We removed the mailer instance from outside the code. So if you come down to line number 19, you no longer have the mailer object on your hand. So you don't need to go to documentation. It's very clear now that the mailer is a use and throw object. You don't have any intention of carrying forward with it. It's done. One good news in this code is we kind of contain the lifetime of the object fairly well. But the problem with this code, though, is it's still noisy. It would be really nice if we can eliminate this noise. Well, let's try this. Let's go ahead and get rid of this mailer from here. Let's go ahead and get rid of this mailer from here as well. Let's go ahead and get rid of all these ceremonies of parentheses around this code. Let's get rid of all these semicolons we put around this code. And of course, we can kind of drill it down. I'm even a fan of a single quote instead of a double quote because that's less noisy. So you can kind of go on with this, and we are kind of removing all these ceremonies in the code all the way down. So it kind of trickles down to a bare minimal, as you can see, except it doesn't work. Sad. So what do we do to make this work? Well, it turns out that the mailer.send is calling this block of code the closure. Up to this point, you can do in almost any language that supports closures or Lambda expressions. What I'm going to show you next is something very special to Groovy. Groovy has an interesting feature called the delegate. So what that really means is, if I'm a closure, I have a reference to a delegate object. If you call a method on me, if I understand what that method is, I'll respond to you. But if I don't understand what that method is, I won't complain. I'll quietly forward it to the delegate and say, hey, you delegate, do you know what this means? Can you handle this? If the delegate can handle it, life is good. Otherwise, you get an error message. So the trick here is simply to delegate this call. So notice what I'm going to do. I'm going to say block over here dot delegate equals mailer, and I no longer have to pass the mailer anymore, so we can easily route that to the delegate object. Now, of course, there's a good news and a bad news. We got this working, but there is one thing we need to keep in mind. Look at what I did in line number 8. I took the block, which is the parameter I got, and I stuck a delegate on him. Now, we all know changing an input parameter is crime punishable under law, right? We should never do this. Imagine this code is multi-threaded. That's going to royally mess up now. So how do we deal with it? Well, we don't want to change the input. Instead, what we could do is we can simply clone this object. So what I'm going to do here is to first say block clone and equals block.clone. I'm going to clone this object real quick. And once we clone this, I'm going to say block clone.delegate and then call the clone itself. As you can see in this case, we made a copy of the input block and then changed the delegate on it. Well, that's great so far, but those of you who know Groovy look at this and say, wait a second, that is 3 lines of code. In Groovy, you never write 3 lines of code to do simple things, right? It's got to be one-liner. Well, fine, if you want only one-liner, we can still do that. You simply say mailer.width, which is the mailer we are creating here. So mailer.width, and you just simply say block, and that takes care of the entire work for you to clone the object and then invoke the method on it, and all that works fine. So we implemented this pattern here, but now take a look at only the code that you see up here for a second. When you look at this code, how does it look like? It doesn't look like code per se. It looks more like kind of a data input or a configuration. Well, we just created a DSL, a domain-specific language that didn't require a special parser to parse it. Becomes extremely easy to write and implement, as you can see. So this kind of format is very compelling. It becomes easy to write this code, and you didn't really put much effort at all to write this. You can see the power of this pattern. You can see this quite often being used in frameworks like Grails, for example. A lot of other things like Gradle and various other tools like Spark make use of these things very easily. This kind of a fluent syntax is extremely beneficial for getting things done. So we looked at the Cascade pattern and, of course, the fluency we get from it. The next thing I want to talk about is the so-called execute around method pattern. And for this, I'm going to use Scala just to give you an example, even though you could use almost any language for this that supports Lambda Expressions. But let's pretend for a minute again that we are dealing with Java code. And I have a public class resource in Java. And the resource has a constructor. We'll call it public resource. And this is going to be saying something like creating, right? So creating. And let's assume that this is the method to create a resource, right? So this is a method to create the resource. Imagine this is Java again. I'm not writing a full Java code here. And then I have a method called, let's say, op1, which is going to simply say operation 1. So let's say op1. Again, assume this is Java. I'm not putting real Java code here at this point. And then I, of course, have a close method. And the close method is going to do a cleanup. So we'll say a cleanup. So here we are with the cleanup method, right? Now, how would I use this? I'll create a resource. I'll say resource equals, and then we'll say new resource to create it. And then once I create a resource, I can say op1 to call the method on it. Imagine this is a Java code. Now, what will happen in this case? We will create the resource, we'll call the operation, but will not get garbage collected right away because we didn't really ask the garbage collection to happen. Well, good news, Java has automatic garbage collection. Bad news, garbage collection is not instantaneous, right? The garbage collection in Java is kind of like the garbage collection in my neighborhood. They say, yeah, Venkat has garbage, who cares, right? We'll take care of it eventually. Now, what if this is a very expensive resource? This reminds me of an experience. I was at a client site, and the client said, our program has some problems. Can you do a code review and maybe in the process help us fix the bug? And I asked the manager, what's the problem? He said, go talk to the programmers. I went to the programmers. One programmer explained this the best. He said, our program works fine most of the time. I said, that's great. When does it not work? He said, it doesn't work from 7:30 to 9 in the morning. I'm like, wow, this is awesome. How predictable it is. Every day? He said, no, only Monday through Friday. It works fine on Saturday and Sunday. So I'm like, what's going on here, right? And as I started looking through the code, I realized that this particular code was using a database connection. In the constructor, they were opening connections, and they had written a finalize method. In the finalize method, they were closing the connection. Well, the JVM said, I got a lot of memory. There is no reason to garbage collect. So it was keeping on accumulating these objects. Too many database connections. It was throwing errors, which was not being propagated properly, so they didn't know why this was failing. Once I found this out, I realized you need to garbage collect this particular object fairly soon to release the database connection, isn't it? So we wrote a close method. And then once we wrote the close method, we can call the close method, and immediately the close method, of course, would run and will clean up this object, right? So we could do that. But here's the question. Is that enough to call the close method and clean up the object? What do you think? Not really, isn't it? Why not? Because the reason is we need to worry about exceptions, isn't it? If there was an exception in the code, then the close will never happen. So you need to make sure the close happens properly as well. So what you have to do is to put a try block, and then within the try block, you call the op method, and then within the finally block, you have to call the close method. And this would make sure that the close happens when you leave the block. Make sense so far? But what do you think of this idea? Tedious, isn't it? I would forget to do this most of the time. This is not very friendly at all. Well, what does Java 7 have? Java 7 has a wonderful feature called the ARM feature. ARM stands for Automatic Resource Management. So you basically do a try over here, and then within the try block, you can call this code. You don't have to really call the close anymore. You can simply write code like this. Of course, for this to work, your resource has to implement auto-closable API. What do you think of that idea? I'm not a big fan of this approach. The reason I'm not a big fan of this approach is you still have to remember to use the try block. And what if you forget to use the try block? Then you blame the programmers. If you only know how to code, right? I don't like this feature. In fact, I would say never trust a feature which has the name management in its name, right? So that is why I don't really like this. Well, just kidding. So the point really is this is not a great feature because it still requires us to remember how to do this. But what if there is no way to forget? What if there's only one way to do it and that's the right way to do it? This is where an interesting pattern called the execute around method pattern comes in. Let's see how we can use the execute around method pattern. Well, the first thing I'm going to do here, let's go to resource. So resource, I'm switching back over here to Scala here for a second. Let's say resource equals new resource, created a resource object, resource.op1 and resource.close. I've called these three methods over here in Scala, right? So we call these three methods here in Scala. So I've got a resource object, and I'm going to call these methods. Of course, this is Scala. I don't have to do this much work. Let's just say define these resource constructors. And we basically, this is a constructor in Scala. I don't need to put that stuff. And this is a define method. This is going to be op1. I'm quickly converting this to Scala code here, as you can see here, so we can actually try this out. And here is the close method I'm going to call. So this Scala code basically creates a resource, calls op1, and cleans it up. What am I going to do? Of course, you still have the same problem here in Scala. You got to put the try and finally block. Who wants to do that? So here's an idea. Let's go to this constructor first and make the constructor, well, actually, let's do something else. Let's make the close method private. How about that? So we made the close method private. The programmer is going to come along and say, I can't call the close. Of course, you know what program will do. Fine, I'm not going to call it. Well, okay, that doesn't solve the problem entirely, right? We'll go to the second step, and we'll make the constructor private. So now we made the constructor private. Now the programmer is going to look at this and say, darn it, how do I even create an object of this class if I don't have a constructor that I can call? Now we got the programmer's attention. There's only one way, the right way to do this. So now we're going to go back to this code. I'm going to write a static method. Well, in Scala, we don't quite write static methods. We create the so-called singletons. So we're going to create a singleton. So the singleton here is called resource over here. And this resource singleton is going to simply define a method called use. And that's going to take a block of code. This block of code is going to take a resource as a parameter, and it's going to return nothing. By the way, normally we use the word void to say nothing. In Scala, you don't use void, you use unit, because then nobody would understand what it means. So that's a better word, isn't it? So unit basically is a void. Why can't they call it void? Okay, so basically in this case, I've got a little unit that it's going to return. But what's the use doing? Use says, give me a block of code, and I'm going to work with this block of code. Now notice what I'm going to do. I'm going to say resource equals new resource. Hey, but notice that I'm creating a resource, but this is being created within the singleton, but singleton is a buddy of this class, so it has access to the private constructor. Once we create this object, I'm going to pass this object within the safety harness of the try and finally block, which, by the way, I can remember to write once as the author of the class. And then within this, I'm going to clean up by calling the close method. Now, within this, of course, I'm going to call the block and send the resource. Now, how did this really change the game? Well, the beauty of this is, notice, we structured the code with the use block. Now, as a user of this code, you would say resource.use. You would write a block of code. You would say resource is being passed to me. So you would say resource. And within here, you call whatever methods you want to call, like resource.op1. But the beauty is, when you run this code, the first beauty is, this is the only way you can write the code. You cannot create an object directly by using a constructor, so you cannot say, oops, I forgot to call close. But the beauty is, when you call this method, as you enter the block of code, notice the construction happens. It yields a response to your code. Your code does whatever it wants to do. And when it's done, when you leave the code on line number 20, the cleanup happens automatically. We have used this particular pattern in quite a bit of code to clean up resources. You can see this example in Groovy, for example, when you use file operations, you say file work with, and it'll just use the file and release it. In an application I was working with, we use this for transaction management. We got transactions to create, we got transactions to close. It became a burden to do this everywhere in the code. We simply said, transaction.run in transaction, and then we would just wrap the code right in between. A transaction is created, handed off to the code, we use it. When we leave, it'll smell the transaction and see if it's broken. If so, it'll abort the transaction, otherwise it'll commit it. So this became a lot more easier to work with in the code by using this kind of operation. So this is called the execute around method pattern, and we saw how we can use this. And the beauty is you can use this in almost any language out there today, and that is supporting Lambda Expressions. That's one of the beauties of this. The next pattern I want to talk about, I'm going to skip the next two because we will not have time for it. If we do have a time, I'll come back to it. But just to be fair, I want to show you some example in Java so you kind of get a feel for what can Java do. Now, when I say Java, I want to use Lambda Expressions in Java. We're really looking at something being developed right now, but I'm just curious. I want to kind of look ahead and see what is in the making. I'm going to show you an example of how we could program in Java. Everything I showed you now in Scala and Groovy, almost all of it you can do in Java as well. So let's take a look at an example of that. Now, I talked about the imperative and functional style. So to understand this, I'm going to use a little example here to show you how we can actually use a pattern. And the pattern I'm going to call here is called the function composition pattern. It's a very powerful pattern. And when Lambda expressions become available, I hope we will be doing more of that in Java as we write code. Let's take a look at an example here. I've got a list of stock symbols on my hand. So I'm going to say tickers.java. And I got a bunch of stock symbols. I don't know how many I have, maybe 20 or so I have. I want to go out and find the price for each of these stocks. And then once I find the price of each of these stocks, I only want to group only things which are less than $500. And then among those prices, I want to just display the one with the highest price among the 500. Let's look at how we're going to write it. Do me a favor, if you can keep count of the number of lines of code I'm writing, that would be really great. All right, let's get started. How many lines of code have I written so far? 0. All right, just to set the count to 0, right? So list of string, and I have stickers. We'll call it tickers equals tickers.symbols, right? So I got a stickers.symbols on my hand. Great. And let's just go ahead and print it out and see that the tickers are being printed. I'm taking baby steps here, one step at a time. So we got the tickers. Great. This is Java code. Now what am I going to do now? I'm going to go through and say for stock info. So I've got a stock info object, but I want to create a list of stock information. So list of stock info, and we'll call it as stocks with prices. So stocks with prices is equal to, let's say, new array list of stock with prices. So I created a array list. This is an imperative style, right? So now I say, what do I say here? String ticker in tickers, right? And I'm going to loop through. How do I find the stock price? Well, I'm going to go to Yahoo Finance and ask for the stock price. It's fairly simple. You send a request to the web, and you get a price, and you populate it. To make our life easy, I have a stock util, which has a get price method. If you're really interested, you can go to my website and look at the code. You can see how I'm parsing the web service request. It is not ethical to show parsing code in public these days. So I will not show it to you here. But in the privacy of your home or office, take a look at the parsing code, right? So basically, this is going to be a get price method that I'm going to call. It is called the stock util.getPrice. So let's call that. So I'm going to simply say stocks with prices.add. And what am I going to add over here? I'm going to simply add a stock util and stock util.getPrice for what? For the ticker. So this should give us all the stock prices. So let's go ahead and print out stocks with prices. And this should go out to Yahoo, find the price for all these stocks, bring it back to us, assuming I didn't make any typos. This should go back and bring the prices for us. Am I making sense so far? Fairly simple, right? So we just populated all the stock prices at this point. Now that we have all the stock prices on our hand, what's my next step? My next step is going to be to go through this collection and only take stock prices less than $500 in the price. How would I go about doing that? Well, that's going to be another imperative external iteration loop, as you would know, right? So let's do that. So what am I going to do now? I'm going to say here, list of stock info. And this time it is going to be what? Stocks less than 500 equals new array list, one more list. And what do I do now? I'm going to say for stock info in stocks with prices. And this is going to simply say if the stock util dot, and I have a little method called is price less than 500. So is price less than 500. And what am I asking for here? Given a stock info, and I want to know if the given stock info is less than 500. So if it is what? Then I'm going to say stocks less than 500 dot add. I'm going to add the stock info to it. So right there is the stock info. Once we are done with it, we can print out, if you want to, the stocks less than 500. So 2 steps I did so far. Imperative, the good old way of doing things. Go to the symbols and create a list of all the stock prices. Go to the stock prices and get stock prices less than 500. Making sense so far? That's all I did, right? And how many lines of code did I write so far? All right, that's a good, fair point. You're still thinking, that's good. That's the way it is in Java, isn't it? Well, let's see what it's going to happen. We'll change that in Java also. So now I'm going to say high priced. So stock info high priced equals new stock info, an empty stock at priced 0 to begin with. And now I'm going to simply say for stock info in what? Stocks less than 500. And this time I'm going to say high priced equals stock util. And I'm going to use this method called pick high. So pick high is going to take 2 prices. The stock info I have on my hand. Oops, so let's say stock info. And I'm going to get the high priced. So it's going to compare these 2 guys. When it is all done, I'm going to simply print out the high priced stock. So how much time is this going to take? We'll find out in just a few minutes. But let's look at the code structure so far. We went through the loop. We first went through the string of ticker symbols to collections of stock prices, from there to ones less than 500, finally to the high priced. So this is going to the web and finding all this price detail. We'll put the timer on this and see how much time it takes in just a few minutes. That comes only a little later. We'll worry about it a little later. But what does it say? It tells me that the high price, did it do the job actually? Probably not. That's because I have a printout here, which I don't want. So let's get rid of that. So this should only tell us what the total price is. Before I run this, let me put the timing on this. So let's say start equals system.nanotime. So we can know how much time it takes. And then in the end, we will say end equals system.nanotime after we compute this. So end equals system.nanotime. And then finally, we will say time taken. So we'll say time taken 1, and this is going to be what? End minus start divide by 1.09 seconds, right? So that's basically going to tell us how much time this took. While it's doing it, let's think about how this will be done in a functional style or in a function composition. Well, let's think about this a little bit differently. We got a collection of ticker symbols. We want to go from a collection of ticker symbols to a collection of stock prices. You saw me do this already in the beginning of the session, right? I used a collect method in the case of Groovy, and I said you could do this with map in Scala and Java also. So we could use a mapping operation. Now that I have a collection of maps, what do I do? A collection of prices, what do I do? I want to get only prices less than 500. What's that operation? It's called filtering operation. I'll filter it. Once we filter, what do I want to do? I want to reduce this down to just one value that I'm interested in. That's all I care about, right? So let's do all of that. How would I do all of that? Before that, let's see how many lines of code we had over here. That's 1, 2. Let's ignore the print statements. So that's 1, 2, 3, 4. About 20, 21, 22 lines of code. All right, keep that in mind. So how do we do this? Let's say start equals system.nanotime one more time. End equals system.nanotime. And I will print out the time. This is time taken 2. It shouldn't take any different time at all. We'll call it time taken 2. But what am I going to do here in this case? I'm going to say print high price. We'll call it as print high price. And the print high price is a function I'm going to create where I take the tickers given to us. Remember the ticker symbols we have. And I'm going to call a method called the stream on it. This is Java 8 feature where we can get a stream of objects from it. How am I going to use this? Well, I need a print height price method to work on this. So let's look at the compose pattern at work now. So I'm going to say over here, a static method called price, print height price. This is going to take a stream, and this is going to be a stream of strings, isn't it? So we'll call it tickers on our hand. So what am I going to do with these tickers? Let's take baby steps. The first thing I'm going to do here, given this collection of tickers, I'm going to say tickers.map. And once I call a map, I've got a ticker on my hand, and I'm going to call stockutil.getPrice for the ticker. So we converted from stock tickers to stock prices. Now we got a collection of stock prices on our hand. What's my next step? My next step is filter that. And what do I have? A stock info on my hand. And what I want to do from the stock info basically is I want to get only prices less than 500. So stock util one more time. And we will say over here is price less than 500 for the stock info 500. Notice I'm doing the same operations we did on the imperative style, but only more concisely here, right? So we went from a collection of tickers to a collection of stock prices to a narrowed down collection of prices only less than $500. Now I need to reduce this. So the last step is reduce. And what am I going to reduce this to? I'm going to reduce this. I've got a stock price, stock 1 and stock 2 on my hand. And I'm going to reduce this to stock util. And the method I'm going to use is pick high, which takes stock 1 and stock 2 as parameters for us. So given this operation, the last step is to get the price that I'm interested in, and I simply want to print it out. So let's say output that, and I want to just print out that value that we received through this particular operation. So this is Java 8 Lambda Expressions at work, but what did we just do? We simply transformed, did a function composition. So we simply said, given a collection of stock symbols, go to a collection of prices, narrow down to prices less than 500, and print out the high priced, and assuming that goes through the web and gets the information for us, it should print out what the highest stock price is. Now, of course, both of those calls are sequential in this particular case. The result, hopefully, is the same, unless the stock prices rapidly changes while we are looking at it. And then, of course, the price should be the same, and it should print out. But notice the code. We wrote one line of code, maybe a little longer, a compose pattern, but very concise. And notice how we are composing this function one step after another after another. And you can see that the result of both the operations are the same. And the functional style appears to be just a notch faster, but don't believe that, right? So it's simply the same amount of time that both of those took. Does it make sense so far? So which one would you prefer, the bottom code or the top code? The top code. Unless you're a consultant writing code and getting paid by the number of lines of code you write, right? So of course the top one. But there is a little bit more bonus for you on your hand. So what is the benefit? The benefit is not only the conciseness we got in the code up there, but there is another added benefit on our hand. I'm going to just copy this over and just for a minute. And I'm going to make only one change between these two code. I'm going to change this to a parallel stream. So that is all the change I made in the code. I didn't change anything else. Now we are telling Java, I don't want to go to Yahoo one ticker at a time. That is slow going across the internet. Why don't you do this fast? Send all the requests to Yahoo. Yahoo is going to sit there and say, whoa, last time you came at one price at a time, now you want all these at the same time. That's Yahoo's problem, right? So fire all the requests at Yahoo and say, give me all the prices. I want to filter all the prices parallel, and I want to reduce it. And all that I did was change that one line of code from using a stream down to a parallel stream. And what is this going to do? It is going to just open up the pool of thread from the executor service, fire those requests in concurrently, send the request to Yahoo, and have that process concurrently. And when the request comes back, remember the slowest part of this is going to Yahoo and coming back. And that shouldn't take that much time when you do it concurrently. And you can see that the result came back in less than 4 seconds. And the effort it took to parallelize the code was just changing that one little piece of code that was very, very convenient. So you can see how the function composition not only made life a lot easier, it also made it extremely simple to go ahead and parallelize the code also. So the point I'm getting to here is that we have looked at design patterns over the years. We have looked at what patterns can provide for us, but a lot of times the patterns end up being a bit heavyweight when we kind of apply it. But with Lambda expressions, we have a real power on our hand, and we are able to really use patterns a little differently. We could use similar patterns to what we have used before, like the iterator, but we can use internal iterators now. We could use the patterns like we did before, but strategy patterns. But rather than creating a hierarchy of classes and interfaces, we can simply use Lambda expressions to create them. And the beauty is, you could do this in almost any language today. I mean, even C++ supports Lambda expression, for crying out loud today. So you could do this in almost any language, including Java 8, as you can see. You can certainly do that in this language as well. I really hope you found that useful. Thank you. I might have a few minutes to take questions if you're interested. I won't be able to see you, but do speak up. Don't be shy. Any questions, any comments, just about anything. At least ask me how the weather is. Just okay, just some question. Go ahead, please. The question, wonderful question. How do you make the top code readable for another developer? Let me say a couple of things. It's a really good question. Let me say a couple of things. The first thing about readability of a code is somebody has got to understand the syntax and the language. That's the first thing. I can't complain going out on the street here and say, all the signs are unreadable. That's kind of stupid on my part to say that, right? I got to learn your language before I can read the signs. But then, of course, once we know the language, know the syntax, how do you make the code readable? I'm going to tell you something about how to make a code readable, and this is the only way I've found out to make a code readable. The only way to make a code readable is to read it. Simple. So never keep the code to yourself. Write a piece of code and give it to somebody and watch their head hurt. And then they say, what in the world are you doing here? And you both sit down and refactor the code, and the code is readable. You know, I could pretend that I can write readable code, but honestly, I cannot. I suck at writing code. But what I noticed over the years is, while I cannot write good code, I'm extremely good in finding fault with other people's code. So I realized, rather than pretending that I can write good code, I write crappy code real quick, give it to somebody else, and while they're critiquing my code, I critique their code, and at the end of the day, we both have better readable code. So my recommendation is, to make the code readable, go read it. Make other people read your code. Then we know that we are understanding the code. But of course, the first step is to understand the syntax. And to give good variable names. If you noticed one thing, I tried my best not to do something that you would see most people do. Most people, when they're writing code, they would write code like this: S, S1, S2. I try not to do. I don't feel compelled that the code has to be very, very short. There's a difference between the code being concise and the code being terse. And a concise code is readable and maintainable. A terse code causes ulcer, right? And we don't want to have terse code, so I don't use single-letter variables for that reason. I would give explicit, more meaningful variable names so we can work really hard to make the code readable, but have other people read the code as well. I think I can take one more question at least. Please. What about debugging? I don't write code with bugs, so I don't know. The answer is no. The reason why it is not more difficult is that the first thing is functional style code really is favoring immutability. So unit testing such a code becomes extremely simple compared to a code that has mutability in place. So it's easy to define what the code is doing. It's, in fact, the whole mathematical underpinning of functional style came from the background of mathematical theorem proving and code quality, code correctness proving. So basically the idea is, it's easier to express this code, it's got fewer errors. Then of course, added on top of that is the debugger support. But your Java tools, when they begin to support Java 8, they will help you debug your code just the way you debug Java code today, would be no different whatsoever. So it wouldn't feel any different, except that you probably would need a little bit less debugging than we did before. That would be the only difference. Did you have a question or a comment? No? Any other questions? One more maybe? No? Yeah, please. Great question. How about using Guava? Well, Guava and other tools are fantastic, but one of the biggest problems with those tools today, as of today, is they still have to undergo the ceremony of Java. It's like putting a lipstick on a peg, right? You cannot get away from that. But the beauty is, Java 8 Lambda expression makes code really concise. So those libraries will actually grow to become more powerful, and they can make use of concise Java code. So that would be the benefit. That's all I have. Thank you very much.